Word document. This is the third question. First and second we did last time. This is the third one. This one. So this is the one I just copied and pasted. So see differences over here. Now you're going to do differences in age are normally distributed, differences in age are not normally distributed. This is the K statistic. That's the p-value. Sig is significant, that's a p-value, which is greater than alpha. Alpha was 0.05 in that problem. Do not reject the null. That means keep the null. That means this is the one that you're going with. Keep the null. So at 5% level of so paired differences in age are normally distributed at 5% level of significance.
Quick question. For like pen and paper, like for homework 8, for instance, the question 3 is a pairs test. How would you check normality of the difference there?
You wouldn't check. It should be given to you. The assumed differences are normally distributed. Check if it's written on there.
Yes. Sorry. Thank you.
So when you're doing these hand calculations, something has to be given because you don't have the actual data there.
Yeah.
And once you have your data, and you as a responsible data analyst should be checking all assumptions before using a certain test. Okay, you don't have to start doing an independent sample t-test with this data, even though you have 2 columns. So, is this clear that differences in age are normally distributed? You have a do not reject. So you're doing the same thing. Pair of hypothesis. And every time you do this, check. You have your pair of hypothesis, you have your test statistic, that is the KS test statistic of 0.132. You have a p-value, and here it was greater than alpha. So you have a decision based on the p-value, and then you have your conclusion as to whether the differences are normally distributed or not. So if differences are normally distributed, you can use paired sample t-test. And it was a 2-tailed test, I think. Is there a difference between the age? Check and tell me, is it a 2-tailed test? Okay, now you're doing your compare means and proportion. You're now going to the paired sample t-test. Last time we did independent sample t-test, both for pooled and non-pooled. Now you're in paired sample t-test. And the box looks a little different. So now you're doing, this is the first group. So put that husband's age there. That's the second group, put the wife's age there. If you reverse these, if your wife is the first group, put wife here, put the husband there. You have to decide who is your first group and who is your second group and accordingly get it. I'm just following what we did in our hand calculation so that you can compare the output there. And you don't have to do effect sizes. So don't keep this checked. If it is checked, you'll get some extra output, ignore it. They asked for a 95% confidence interval, that's by default. If they ask you for a 90, go here under options and change it to 90 or 99 or whatever, 98, whatever they ask you. Ours is 95, so we don't have anything else to do. So now you're going to have 3 tables over here. This is one. You have a little correlation table, and you're going to have the paired sample test. And you're going to copy and paste all 3 of them for this paired t-test. So this is the first one. First one is always a descriptive. So they're giving you the average age of those 10 husbands, so that's 50, and this is the average of the wife, and then there's some standard deviations and other things. They also give you a little correlation table, basically telling you that the 2 ages, husband's age and This is just for you to see. So these are dependent samples. Correlation is high. It also happens to be significant. This p-value is really small. But this is just to emphasize that we don't have independent two groups. There's a high correlation between the two ages of husband and wife. So it's a dependent, we have dependent sample. You don't have to do anything with it, just to look at it. This is your actual paired sample t-test. Okay, so we had to, ours was a two-tailed test, so write your t-test here. That's mu1 equal to mu2, mu1 is not equal to mu2, 1 is my first group, 2 is my second group. Or you can spell it out, what was your first group. And then your T, this is your T, there's no other T, that's your T. This is our degrees of freedom, 10 pairs, so n minus 1, 9 degrees of freedom. We have a two-tailed, so you're going to look at this p-value, 0.048. So you have your test statistic, you have your p-value, you're comparing it with the alpha, projecting the H0, and that's your conclusion at 5% level of significance, mean age of husband significantly different from mean age of wife. If you had a one-tailed test, you would use this p-value. And 3 years ago, this wasn't there, this was there in SPSS. They only gave us two-tailed. So if you had a one-tailed test, you would have to divide this by 2 before comparing with the alpha. Now they want to spoon feed you more, so they divided it for you. All you have to do is look at it correctly and write it. But if you get a table like this, then all you have to do is you need a one-tail, so I'll divide by 2. If it's a two-tail, just use as is.
I was, excuse me, I was only able to produce the second of those two, but it's the same thing, including just the one-sided as well. Is that fine?
With the computer?
Yeah.
You were able to produce this first table?
No, the second one.
Okay, yeah.
That's good?
Yeah.
Alright.
The second one is what is in the latest
That's
version.
what I thought.
That's why I said 3 years ago this was the version. Okay? So if I give you output and it looks like this, and you have a one tail, you just have to remember that divide the p-value. Okay, everything else is the same, no change. So you have a borderline significant result, 0.048 is almost close to 0.5, but 0.05, but technically it's less. Reject H0 at 5% level of significance, the mean age of husband, I would say borderline significantly different from mean age of wife. You don't have to worry, just you write whatever. It's less than alpha you're rejecting, you just write your conclusion the way we were talking. They then asked you for 95% confidence interval of the difference, and that's right here. So this is age in years, so 0.044 years and 7.156 years. Husband is the first group. Husband age minus wife age is positive. Both these numbers are positive, which means mean age of husband is more than that of the mean age of wife. And you just have to write that. 95% confidence, mean age of husband is between 0.044 to 7.156 years more than mean age of wife. Does this make sense, this last line? I know it was a little difficult last week when we threw everything in one day. Monira, does that make sense? The first group is bigger than the second group, that's why the difference is positive. So this is what you do for paired t-test. Any question? Okay. Finally, a lake is classified as non-acidic if it has a pH greater than 6. Test the claim at alpha equal to 0.05. And on average, high mountain lakes are not acidic. So this is just to to single sample t-test. Your data is nothing but pH values, and you have 15 such lakes, so 15 different pH values is in your data set. So you're going to use a one sample t-test. What is, how will I write my hypothesis for this? I'm doing a one sample t-test. What are the assumptions of the one sample t-test?
pH greater
We
than.
have three bullets when you were talking about that. Okay, and we keep saying,
I was thinking the claim could be pH greater than 6.
you mean the mean.
Oh yeah,
Mean pH is.
yeah, mean pH greater than 6.
Left tail, right tail, or two tail? Right tail. Okay, what are the assumptions? What are we going to test? You're just going to be using a single sample t-test. But what are the assumptions?
Do we assume that the mean pH is equal to 6?
No.
No.
Assumptions. We're using a t-distribution. You did it on the test. So you're doing confidence intervals. Yes, Richard?
For to use the t-test, we need to assume that n is lower than 30. It's normally distributed, and the variance is unknown.
Okay, so you're using an S,
Yes.
right? Yeah. Yeah, those are the three. N less than 30, population normal, and you're going to use an S. So when you have a sample, any sample, you will be using an S. That's why we did all these t-tests. Everywhere there's an S1, S2, everything's coming from a sample. You don't have anything else. Here our N is 50, less than 30. The only thing we have to check is the population normally distributed? You're going to do that test of normality again. So now this is your 9.15. That's your pH of 15 lakes. And you just do a simple normality test. Something that you're doing again and again. This time it will be just for the pH. Click on plots. That's the table that you're going to be pulling out. Copy and paste on your sheet. That's here, and you're doing the same thing. pH level in lakes are normally distributed, not normally distributed. This is the KS statistic. Feel free to use a Shapiro wheel. It's a good test. You can also do test statistic is 0.980, p-value is 0.968, greater than alpha, do not reject. pH levels in lakes are normally distributed at 5% level of salinity. The other thing is spell out your pair of hypotheses. Don't write population normal, population not normal. Write in the context of the problem. This is about pH, so write about pH. If it's age, write about age. If it's about operative time, mention it. It's all there in the demo. Now you're ready to do the t-test. Go here, 9.15. And now you're going to do your one sample t-test. Everything is here in the compare means. One sample t-test. And put the pH, your one variable data there. But notice over here, you got to put that 6 over here. Don't keep it 0. Get rid of estimate effect sizes, we don't need it, but remember to put, always assuming that H naught is true, put this 6 over there. This is 6, and for your homework, it could be another number, but make sure you put it there. Again, if it's, you can change options depending on what confidence level. We have a 95% in this. So click on that. We finished the normality test. So that's your 2 tables, 1 and 2 for the t-test, copy and paste. Make sure the whole table is on your sheet, copy it and paste it. One sample is basically giving you the x bar and the s by square root of n. And the n, it gives you just the descriptors, which is important. You can see the mean is 6.6, the mean x bar is more than 6. However, we're going through the whole process to test if this is really true or did it just show up. Something more than 6 just showed up in my sample, or is it true for all of these links? Okay, now we are back to the t-test, and that's your pair of hypotheses. This is your t. Your test value should show over here. This is the 6, and whatever you have in your homework should show up here. It shouldn't be 0. That's your t. That's your degrees of freedom n-1, your basic t-test. And you have a one-tail test, so your output is going to be like this. The lower one is the more recent one in the demo. You have a one-tail test, right tail, so this is going to be your p-value. That's your t. And 0.002 is less than alpha, so you're rejecting the null, and 5% level significant mean pH is more than 6. Okay, now your 95% confidence level is not this. Okay, here, this gives you the confidence interval for a difference, so don't write this. Go back to your output, and when you did the normality test, you have the descriptive table, this one. Copy and paste this one, the whole descriptive table that comes from Explorer. So copy and paste that. This is the confidence level. This is the lower limit, this is the upper limit. So 95% confidence, true mean pH of those lakes is between 6.22 and 6.97. This can, if you need a 99% and all, this can be changed. Just go to that Explore window, options. You can change it here if you need a 99% or anything in that descriptors box. Ours was a 95%, so we didn't have to change anything. And so this is what you'll be pulling out, okay, for this project. Any questions? Anyone finished with the project? First finish the homework A, get it out of the system, okay, and then focus on just this. Do the demo problems, make sure you are getting what's coming out and you understand what is happening, and then write. So your format of that project report is going to look just like this demo report. You'll copy and paste what you need, you write all your tests like this in the context of the data. It should be complete. So test statistic, pair of hypothesis, test statistic, p-value, compare with alpha, decision, conclusion. And that's the project is due on Friday. So this is not Thursday if you want to ask anything. So please check all this out before Thursday. Make sure that you are able to do everything with the data.